Building a robot is an exciting journey that combines creativity, engineering, and a bit of science fiction magic. Let's dive into the process step by step. First, we need to define the purpose of our robot. Is it going to be a simple line-following robot, a robotic arm, or maybe even a drone? Knowing what we want our robot to do will guide all our decisions moving forward. For instance, if we're building a robot to help with household chores, we might focus on mobility and object recognition. Next, we move on to the design phase. This is where we sketch out our ideas and think about the components we'll need. A basic robot typically consists of a microcontroller, sensors, actuators, and a power source. The microcontroller is the brain processing information and making decisions. Popular choices include Arduino or Raspberry Pi, both of which are user-friendly and have extensive community support. Now, let's talk about sensors. These are crucial for our robot to interact with its environment. Common sensors include ultrasonic sensors for distance measurement, infrared sensors for line detection, and cameras for visual recognition. Choosing the right sensors depends on the tasks we want our robot to perform. For example, if our robot needs to navigate around obstacles, ultrasonic sensors will be essential. Once we have our design and components, it's time for assembly. This is where the real fun begins. We'll start by connecting the microcontroller to the sensors and actuators. Wiring can be a bit tricky, but there are plenty of tutorials online to guide us. It's important to double-check connections to avoid any short circuits. After assembling the hardware, we move on to programming. This is where we bring our robot to life. Using a programming language like Python or C++, we'll write code that tells the robot how to respond to sensor inputs and execute tasks. For instance, if the ultrasonic sensor detects an object within a certain distance, the robot might be programmed to stop or change direction. Debugging is a critical part of this process, as we'll need to test and refine our code to ensure everything works smoothly. Now, let's not forget about power. Most robots run on batteries, so we need to choose a power source that can provide enough energy for our components. Lithium-ion batteries are a popular choice due to their efficiency and lightweight nature. We'll also need to consider how to recharge or replace the batteries to keep our robot running. Once everything is assembled and programmed, it's time for testing. This is where we see our hard work pay off. We'll run our robot through various scenarios to see how it performs. It's common to encounter issues during testing, but that's part of the learning process. Each challenge we face teaches us something new about robotics and problem solving. Finally, after testing and tweaking, we can add some finishing touches. This could be anything from painting the robot to give it personality, to adding additional features like voice commands or remote control capabilities. The possibilities are endless, and this is where we can really let our creativity shine. Building a robot is not just about assembling parts. It's about understanding how they work together to create something functional and innovative. Whether it's for fun, education, or a specific task, the skills we develop through this process are invaluable. So roll up your sleeves, gather your materials, and let's get building.